Hello, we are finishing up the kinetics chapter, chapter 14. This is going to be part 4. Please make sure you read the chapter. I'm not covering every single thing in the chapter, just some of the high points, the parts that may be a little more difficult. We are looking at the second rate law. It's called the integrated rate law. There's another one called by the integrated rate laws Arrhenius. Please take a look at that in the chapter. So using calculus, we can relate the concentration of A, this is the reactant, at the start to its concentration at any other time. And that's usually delineated with a T. So the integrated rate law is expressed as follows. Natural log of A at a particular time equals negative KT plus natural log of A initially. 0 means initially or at the start, when the concentration of A is at its maximum. We can express that in another way. This is the way that we usually use it in an equation. So take a look at that. And make sure that you learn that. So for a first order reaction, the natural log of the concentration of A at any particular time in the reaction versus time gives a straight line. Take a look. The middle one is the one that we're most interested in. This is the natural log of the concentration of A versus time. And you can see that it gives a straight line. K is equal to the negative slope. For a second order reaction, however, it's 1 over the concentration of A at a particular time versus time, and you can see that the graph is curved. There is the equation, and it is that third graph right there. So in other words, if the natural log of the concentration of A is linear, it's first order. If the graph is curved at 1 over the concentration of A, you know that it is second order. So let's take a look at something called half-lives. A half-life is the time required for the concentration to reach half the initial value. You've learned a little about half-lives. Ooh, big pencil. Before, so half the initial value at any particular time is half the value of what it was at the start. There it is mathematically expressed. For first order, the equation is 0.693 divided by K. And second order, it's 1 over K times the concentration of A at the start. So let's look at a brief example. 2N2O5 yields 4NO2 plus O2. I'm going to give you the concentration of the reactant, that's A, comparing to the rate, moles per liter second. So for the first trial, you can see the numbers, and there's the numbers for the second trial. At the half-life, what do you notice about the rate? Take a look at the half-life. It starts with 0.90 molarity, and halfway through, it's 0.45 molarity. What happens to the rate when it's halved? As you can see, the rate is also halved. It means that the rate of this reaction depends on the concentration of A to the first power. So it is first order. So we can express that as follows. This is the summary of the kinetics for reactions for 0, first, or second order. Sad to say, you have to memorize this. Sorry. It is in the book. You don't have to print it out. It's in the book. Most of these are just plug and chug kinds of things. This is end of part 4. Have a great day.